subjected to a single direction load or single direct load P or direct normal stress. Normal stress, that is because basically it is acting normal to the surface, that is 90 degrees perpendicular to the surface. So that is the reason why it is called as the normal stress. So when you apply this, here we have, so here the length is in px direction, the breadth is in the z direction, and d, that is the thickness, is in y direction. So here original volume is given by, so the original volume is given by volume of the bar, which is D, which is equal to L into B into D. L into B into D. Let delta L will be equal to, let delta L will be equal to the change in length or the change in length. Here what happens, it is when the member is subjected to a tensile load along the direction of the x-axis, then what happens, the length is going to be increased. How this we have seen in the previous video, when we have the length of the bar which is applied and applying the tensile load which is P. In this case we are considering sigma also. So here P or sigma, which is we are talking about. So the length is going to be increased by this much. So naturally this is the member what we are going to get, and this will be the original length and this will be the final length. So we can recollect this particular sketch when we are considering the member here. So change in length, so naturally this will going to be increase. Then what happens to the breadth and depth? So here delta V is equal to change in width, obviously which is going to be decrease because length is increased. So to compensate the volume, it has to have the width and thickness has to be reduced. So here, so this is the original B and D. So in this case this is B and it is D here. In that case we are considered as T, but here this will be the reduction in volume, that is a reduction in the cross section, which is B minus delta B, and here this is D minus delta B. So this is what we are going to get. So delta width is decreased there. Similarly delta D is given by change in thickness or depth. Change in thickness or depth, again that is decrease. So it will going to be decrease. Now differentiating the original volume. So here what we consider? We consider differentiating the original volume. Differentiating the original volume, which is V is equal to L into B into D. So that is given by delta V will be equal to L into B into delta D plus B into D into delta L plus B into D into delta L, then L into D into delta D. So this is how you will going to get this. So therefore volumetric strain which is epsilon B, which is given by delta V by B. So here delta V is given by LB into delta D plus BD into delta N plus LD into delta V. So that is divided by the original volume L into V into D. So therefore you will going to get, so in this case L into V will get cancelled, so that will be equal to delta D by D. In this case BD will get cancelled, so delta L by L. In this case LD will get cancelled plus delta V by D. So now therefore that is we have epsilon D will be equal to, what is delta D by D? Delta D by D is y direction, so epsilon y plus delta L by L, which is epsilon x, plus delta V by B, which is epsilon z. So this is the volumetric strain along this epsilon V, epsilon x, epsilon y and epsilon z. Now strain in the direction of load, now we will go to consider. So what will going to be the strain due to the application of load now? So due to the application of load, that is, so the load is applied in the direction of x. So strain in the direction of load, strain in the direction of load, strain in the direction of load, that is epsilon x. Load, that is epsilon x will be equal to sigma by E. So this is basically because stress, that is according to Hooke's law, sigma is proportional to epsilon, therefore sigma is equal to E into epsilon, but what we want is epsilon, therefore that will be equal to sigma by E. So that is the expression which we are going to be used here to get this. Next, strain, the lateral strain in the direction of y. So the lateral strain in the direction of y. In the direction of y. So which is the direction of y? It is delta D. So this is the direction. So delta D, that is epsilon y is given by delta D by D. So that will be equal to, what is Poisson's ratio? 1 by m is equal to lateral by longitudinal. So what I want is, I want the lateral, that is equal to 1 by m into longitudinal. Here there is the lateral dimension, what is happening? It is decreasing depth or thickness. So naturally epsilon y will be equal to minus 1 by m into longitudinal direction. So what is the longitudinal strain? The longitudinal strain is nothing but epsilon x. So minus 1 by m into epsilon x. So now again the lateral strain in the direction of zz, which is epsilon y or epsilon z. So therefore similarly the lateral strain is given by in the direction of zz. Similarly lateral strain in the direction of zz, again epsilon z will be equal to, what is that? Z direction, that is we are talking about this direction, which is parallel to this is B, which will be delta B by B. Again the same explanation, 1 by m into epsilon lateral by the longitudinal. Since there is a decrease in thickness or a decrease in width, so naturally it should be negative. Therefore epsilon z will be equal to minus 1 by m into longitudinal. Longitudinal is epsilon x, so you are going to get epsilon x. So now we have this. So what is the volumetric strain? That is the volumetric strain epsilon v, which is given by, so what is epsilon v? Epsilon v is nothing but epsilon x plus epsilon y plus epsilon z. So that will be equal to, what is epsilon x? That will be equal to sigma by E minus 1 by m into sigma x we can take in this form. So that will be equal to sigma by E minus 1 by m into sigma by E. So why we are writing this? Because basically epsilon is nothing but the sigma by E. So we are substituting the value of epsilon x, which will be sigma by E, 1 by sigma by E minus 1 by m into sigma by E. So which will be equal to sigma by E into 1 minus 2 by m, which will go to be the volumetric strain. So here that is also equal to epsilon x into 1 minus 2 by m, which is again, what is epsilon x? Again it will be delta L by L into 1 minus 2 by m. So this is going to be the volumetric strain of a rectangular member. Therefore, volumetric strain epsilon V is given by volumetric strain epsilon V, which is given by sigma x by E into 1 minus 2 by m. Sigma x can also be written as epsilon x into 1 minus 2 by m. What is epsilon x? It is the strain in the x direction. So the strain in the x direction is nothing but it will be delta L by L. So that is equal to delta L by L into 1 minus 2 by m. That will be equal to delta L by L into 1 minus 2 by m. So these are all the various ways in which or various forms in which we can write the formula, so that it is going to be helpful for us when you